Okay, good morning or afternoon, whatever time of day it is for you. What I'm going to have you guys do is, of course, fill in the date. Today we're going to talk about sketching and analyzing graphs, and these, of course, are graphs of functions. I gave you a yellow piece of paper yesterday. What I need you to do is cut out these two activities. So activity 1 is kind of in the middle of the page, and then all of activity 2 with questions A, B, C, D. So go ahead and pause the video right now, cut those out, and then come back to the video once you have that done, because I'm going to keep on moving. All right, so what we're going to do is glue in activity 1. Okay. And it says work with a partner, use the graph below. Okay, so obviously we're not going to be working with partners right now. You're just going to be working by yourself and listening to me. So it says, part A, how is this graph different from other graphs you have studied? Okay, so if we look at this, clearly there's some things missing, right? We don't have increments. Okay, we don't know what the time span is. We don't know, is it minutes, seconds, hours? We don't know if water level is feet, inches, centimeters, right? So there's no increments on this graph. We just know that over time, something is happening with the water level, okay? Write a short paragraph that describes how the water level changes over time. So if I was going to write a short paragraph, I would say the water level is constant, right? It's at the same level, and then the level increases, and then it's at the same level for a little bit, and then the water level decreases again. So we start out with the same level because, sorry guys, because of course the level isn't changing. So we start with the same level, then the water level increases. And I know it said write a paragraph, but we're just going to kind of go through each step here. Oops, sorry. Right? And then it stays at the same level for a while. And we don't know how long that while is because, again, there's no time. We just know it's over time. And then the water decreases. The water level decreases. Okay, so we have the same level, increase in water level, same level, decrease in water level. All right, so what situation could this be? So we have to ask ourselves, in what real life situation do you have water level at a certain point, and then it increases for a little bit, and then it decreases again? So I'm going to pause, let you guys consider, ponder, think, brainstorm. So the first thing that comes to my mind is if it rains a lot. Do any of you have backyards where like there's kind of like a little bit of a dip? And so when it rains a lot, it looks like you have like a lazy river between like your yard and your backyard neighbor's yard. We get that in my backyard. So between my backyard and my backyard neighbor's fence, it'll look like we could take rafts out there and just lazy river it all the way through between that whole line of where backyards meet. So I'm going to say that this reminds me of when it rains a lot and I get a lazy river in my backyard. For a bit, and then of course the water decreases. And I don't think it's like decreasing as much as it's just like displacing. Is that a science word? Like either it evaporates or it finally drains or whatever. We're just going to put disappears. And I'm going to put that in air quotes because it's not really disappearing. It's just going to a different place. It's just no longer in my backyard, right? Maybe you thought of a river, like river is one height, like one depth, okay, and then it rains a lot, so the river seems to get the water rises up on the banks, and then it decreases back to its original. So lots of different ways you could go about that one. All right, now we're going to turn to the next page and glue in activity 2. Okay. Because it's not going to fit on the same page as activity 1, which is fine. Now. It says work with a partner again. Okay, so again, you're by yourself listening to me, but it's fine. You are riding your bike. Match each situation with the appropriate graph. Explain your reasoning. Okay, so we have 4 different graphs here. Again, we don't have increments, so we don't know how long this person's riding their bike or what kind of speed this is, but it's just somebody riding their bike over time, and this is their speed. Okay, so we're going to try to match graph A, B, C, and D with situation A, B, C, and D. So let's make sure we can see all of the situations here. All right, so A says you gradually increase your speed, then ride at a constant speed along a bike path. You then slow down until you reach your friend's house. Okay, so if you are increasing your speed, then you're at a constant rate, and then you slow down until you reach your friend's house. Let's read the other ones. You gradually increase your speed, then go down a hill. You then quickly come to a stop at an intersection. Okay. You gradually increase your speed, then stop at a store for a couple of minutes. Then you continue to ride, gradually increasing your speed. Okay, well, I think that C is going to go with D because this shows that they're not actually moving in this section, right? There's no bike speed happening. So I'm going to say that this is the person that went to the store. So we're going to put a C here. We're going to cross out C because now we've used it. The last one is you ride at a constant speed, then you go up a hill. Once at the top of the hill, you gradually increase your speed. Okay, so we gradually increase our speed. I'll let you guys look at that for a second. Let it all sink in. All right, so let's look at this again. Ride at a constant speed, you go up a hill. So what happens to your speed when you're going up a hill? Are you going faster up a hill or slower up a hill? If you're me, you're going significantly slower. So for a constant speed, of course, we would have the speed not changing. I know this looks like I'm actually going down a hill, but this is actually me slowing down as I go up a hill, right? So then when I'm at the top of the hill, I gradually increase my speed because now I'm going down the hill. So this kind of actually looks opposite of what our brains want to think, right? You slow down, so it looks like you're actually going down a hill. So D actually matches with graph B. Okay, so then let's look here at A. You gradually increase your speed, then ride at a constant speed along a bike path. So between these two, which one has what looks like a constant speed, where your speed does not change? Hopefully you're thinking of this graph. So this is actually A. And then all we're left with is B. You gradually increase your speed, then go down a hill. So even though this looks like I'm going up a hill visually, this is my speed increasing as I go down a hill, right? Then you quickly come to a stop. So your speed is like abruptly stopping. So this would be graph B. So that's all I wanted you guys to do today. I know, pretty straightforward and easy. We're just going to analyze some graphs today, and then what's going to happen tomorrow on Monday when I see you is we're actually going to sketch some graphs. Okay, we're actually going to look at the words and we're going to create what the graph should look like. Okay, I hope you have a fantastic weekend. Thank you for doing your notes today, and I will see you Monday.